college champ.
Mr. Shardy on big screen.
Not any longer.
Nope, now PowerPoint on big screen.
No, that's 7th grade. We want algebra 1. All right. How many people from pre-algebra remember doing exponents?
I
Okay.
Easy class.
It is an easy class, and I will literally tell you, with few exceptions, this is the same class as pre-algebra. Like, I didn't change much. What is going on here? That's
No
wrong.
school.
Clearly, I didn't update my calendar. This is not the droid you're looking for. This was last year. I taught this right before Thanksgiving. All right. Here's your homework. Copy down. Looks like a lot of these are quickly done. Quickly done.
30 seconds.
I should have said, and I apologize, I should have said, hey, you need calculators for today. Now, if you have your calculator, get it out. Don't use it until I say so, but I definitely want to show you. We'll take a break when we get there. We'll take a break when we're not there yet. We're going to do it all by hand first, and I'll show you how to use calculator. Yeah.
If you put an exponential on one of these calculators, can it just automatically do it?
Can it automatically what?
Can it just automatically simplify it?
Yeah.
Sure. Yes. You don't have a book, correct?
Yeah, neither do I. I only have this one.
They knew love. They knew money.
Well, the ones that are colored.
But I can say like less than 100.
What do you do?
And on the same day.
All right, put your calculators down. Tonight for homework, you don't need a calculator to do the homework. I'm just going to show you. Hey, for those of you that have this calculator right here, perfectly fine calculator for pre-algebra and lower. The stuff that we're doing this year, you have to have a graphing calculator. You have to have a graphing calculator. When you take the test this year, you have to have a graphing calculator. You do not take Algebra 1 with this. You can't get to the answer with this. You have to have a graphing calculator. So I'm not going to punch you down, but I'm going to say when you take the PSAT test, it's with a graphing calculator, not with a scientific calculator. This doesn't graph. They're going to ask you to graph. It's going to be something that you can't do by hand. You have to have a graphing calculator. Going forward, I don't care how far you go, right, into college or whatever, you stop at high school, no science class, no math class where you take that you have to have a graphing calculator. It's part of the class. This year, the graphing calculator is part of the class. All right, if you have any issues with that, just talk to me offline, we'll talk about it. All right, exponents. I said that this was an easy class. For most, for some of you, it literally could be the first time you've been exposed. I don't know. You got to stop me. All the kids that I had last year, you had this last year, by the way. It's the same slides. But for new kids, maybe this might be new. So I will talk as fast as you can take it, but you've got to stop me, Chris, if this is new. All right, so here we go. Box 1, write this down, please. We're going to be dealing this entire chapter, and also like literally every chapter from now on, including geometry, algebra 2, pre-calculus, statistics, whatever you take. We're going to be dealing with these things called exponents. Exponents are a way of showing repeated multiplication. In 3rd grade, you were introduced to multiplication. Multiplication is a way of showing repeated addition, right? The shortcut method. We even have a shortcut to the shortcut method. It's called exponents. So exponents are a way of showing repeated multiplication. Multiplication is a way of showing repeated addition. So this is a double shortcut. Okay? In math, I always say we're lazy. We're just efficient. I don't want to write 4 plus 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 4. Just write 4 squared and I'm done. I don't know if I had the right number of 4s there, but you get the idea. All right, Chris, what do you remember about exponents?
That there's one big number and one small number.
That's perfect. That's literally how I describe it. There's literally, physically, I don't mean like 2 is bigger than 3. Clearly it's not. But physically, the 2 is bigger than the 3. It turns out that you can write numbers above on both sides and below on both sides. Science primarily uses the left side. Math uses the right side. It's not always the case, but generally that is. All right. Who remembers what the big number is called? What's the big number called?
Coefficient.
Nope.
Don't be efficient.
Anybody? The big number is called Randy? Nothing? Okay, write this down then. Point to the big number and call it the base. It's called the base. Paul, you remember what the little number was called? One is to the upper right. Chris? Ari, you remember what the little number was called? It's called the exponent or the power.
And 2 to the 3rd power.
Perfect. Good job. All right. So that's the, I mean, you're going to hear me call this all the time. And I guarantee you, if you had any pre-algebra, you had this before where you were given these names. Nobody remembers the base. It's not that important that you remember. I'm not going to give you a vocabulary test. You're just going to have to deal with what's the answer to 2 to the 3rd power. What is 2 to the 3rd power? Guess what it's not?
2 plus 2 plus 2. 8.
It's not 2 times 3.
No.
Everyone
it's 2
thinks it's 2
2.
times 3. It's the base written 3 times.
2 times 2
It's
times
the
2.
base written 3 times with multiplication in between. Therefore, the answer is 8. All right, be brave. I've never seen this before in my life, Mr. C.
I have never seen this before.
All right, so everyone has seen this before. Good. Okay, so in Algebra 1, we use exponents all the time. It's expected that you are, I don't know, fluent with exponents. So this is just the first course of it, or the first class of it. Okay, don't overthink this. This is 13 written 3 times. Okay. This is 13 written.
1 time.
How old are you right now?
14.
14 or 15, right? It turns out that you're not that old at all. You are 14 or 15 to the 1st power years old. Why? Because every number has an exponent. We just choose in math to be lazy and not put a 1. Remember last chapter test we had x all by itself, and I said, no, the coefficient of x is 1. 1 times x, we just choose not to write the 1. So yeah, that's 13 written 1 time. Don't overthink that. Occasionally, here's one example. Well, 13 times 1 is the answer, but that's just a coincidence, right? Don't assume that it's ever base times exponent. Don't assume that. Just write the base, the number of times is the power. Parentheses, we didn't see much of last year in pre-op. Now we start seeing parentheses all the time with exponents. This will cause you problems. Technically, the base is what?
13.
The base is not 13.
Parentheses 13.
It's parentheses 13. You're like, well, what difference would it make? It makes a difference when the 13 is positive or negative. If you see parentheses, parentheses are part of the base. So technically, I'm supposed to write parentheses 13 3 times. Now, in this case, it wouldn't make any difference whether I had or I didn't have parentheses. But it will make a difference when there's subtraction involved or negative involved.
But it's easier because like it actually tells me.
Oh, it does. Oh, you're already jumping ahead, aren't you? This has a form. Tonight for homework, they're going to say, write the number in. Anybody remember this form? Who said that? Okay, cool. This is called expanded form, right? Right here. This is called expanded form. The answer, which is what most kids like, well, what do you want me to do? Write the answer? The answer is called the simplified form. Simplified, didn't we just have a speech about we're going to pay attention? Yeah, but listening doesn't look like that. Okay, yeah, and the eyeballs on the board. Thank you. All right. So for most kids are like, what, you want the answer? You don't want the, I'm not sure what you mean. Well, the answer is called the simplified form. And in order to find the answer, you first have to put it in expanded form. Well, most of you probably already know the answer is what? 6, right?
No.
Why not 6?
Because it has 3.
Please don't make that mistake. I see it all the time, and it's a common mistake. But it's 3 written twice. So we write it in expanded form first, maybe in your brain, not on paper. Right? And then you do the math. That's 3 written twice. The answer is 9. So simplify is writing the answer. So tonight for homework, it's going to say probably expand and simplify. It just means write the answer. For some of them, you're going to memorize. 3 to the 2nd power is 9. you're not going to remember 3 to the 6th power. You're not going to have that memorized. So for others of them, you're actually going to have to do the work. Okay? All right. So box number 2, let's expand and simplify. 3 to the 3rd power will be 3 written 3 times. We go left to right by PEMDAS. 3 times 3 is 9, times another 3 is 27. What's anything to the 1st power? Itself, right? So the base. Technically, I got to write 5 parentheses here, right? But, you know, when it's positive, it truly doesn't make a difference. It will make a difference when it's negative. All right, here's how I do 2s. You ready? I use my hand. My hand, each finger represents a 2. So I've got 1, 2, 3, 4, 5 2s. 2 times 2. So I go 4, 8, 16, 32. I'm just multiplying by 2. 2s are the only one that I can do with my hand. The rest, good luck with that.
You can do 9 on your hand.
You can do 9. So 9, 81. Oh, no, I don't know what to do now. Well, what's 9 times 9 times 9? I don't know what 80. Let's see. I can do it in my head. 9 times 1 is 9. 9 times 8, 72, 721. Okay, but it takes a time. It takes a while to do it. Hey, do we need to do 3 more? You got this concept? It is. Okay. So some quick notes. And this is the obvious one. I see it all the time. Someone's not paying attention, and they simply tell me the answer is 8 because they do 4 times 2. It's not 8, right? It's 16. Now, we have another word for that number right there. Who knows the word? We have another word for this other than power exponent. You've probably heard this before. We say 4.
Square.
We say 4 squared.
Oh, yeah.
Why do we say squared? Well, think about a square with side lengths of 4. Well, this side's 4, they're all 4, right? What's the area of the square? What's the area? That's why we call this 4 squared, because it represents the area of a square, and there's 1, 2, 3, 16 of them here. So that's why 4 to the 2nd power is most often just simply called 4 squared. For me, I remember absolutely freshman year of high school, I was like, she keeps saying squared in the other word, and I don't know the difference between square and the other one. So she never drew this picture for me. Like, it literally means a square. What's the other number we have a different word for?
Cube.
What's the number?
3.
4 to the 3rd power, right? We say cubed. Why do we say cubed? Well, let's think about a volume of a cube. Here's a cube, a Rubik's cube, right? Side length is 4, the width is 4, and the height is 4. What's the volume of a cube? Length times width times height. 4 times 4 times 4. Hey, that would be 4 to the 3rd power. That's 4 cubed. There's 64 tiny little cubes inside that one big cube. That's why anything to the 3rd power is called cubed. Anything to the 2nd power is called squared. I'm going to exclusively say 4 squared, 4 cubed. If you're like me, you're like, there he goes again saying those words. I don't know the difference. You know, right in the upper right-hand corner of your paper so that you're not confused when I say squared or cubed. Is that new to anyone, squared and cubed, or you heard that before? You just, you know, maybe you didn't pay attention, maybe you didn't. Okay. Grab calculus. I know, but let me show you how to do this with a calculator. All right. So, what? All right, go. What? Yes. We will wait 30 seconds for you to return. All right. While they're gone, we're going to make fun of them. No. We're not. Where's your calculator? Why not? You need to bring it to class. We're going to be using your calculator almost every day from now on. All right. So for those of you with the graphing calculator, we are looking for this key right here. It looks like less than or greater than symbol, except it's upside down or turned 90 degrees to the right or left. All right, that is called, literally, it's called the caret key. It's not spelled like C-A-R-O-T. It's called C-A-R-A-T. It's called the caret key. The caret key on a graphing calculator is how you enter exponents. So if we want to do 2 to the 3rd power, you hit 2, caret key 3, and then hit enter. You found it?
No, I don't.
Look right there. So hit 2, caret key, and then 3. And notice on the TI-84, when you hit the caret key, it literally puts the number above. So it looks exactly the way it should look. You hit enter, and you get the answer. The answer to the third is 8. Now, no, I don't want you to do your homework tonight using the calculator, but you got to know how to use exponents. You can also have variables in your exponents. We will see that this year. Okay? We will solve equations when there's variables in the exponent. You get to learn some more challenging solving equations. Hey, what about parentheses? The parentheses are right here. So if you want to do parentheses 4, close parentheses to the third power, you hit parentheses, you hit 4, close parentheses, caret key, 3, enter, you should get 64. Yes? Okay. Questions on how to do exponents with your calculator? Okay. That's it for your calculator. Put it away. All right. Negative is where you will have problems. Last year we didn't mess with negatives and exponents. This time we will. All right. So here are 3 different problems. They're all different, even though 2 of them look alike. Turns out that if you type this into your calculator, you get 2 different answers.
Yep. There you go.
Okay? Grab your calculator, do it.
Oh, you get a negative and a positive.
Turns out that if you type these into your calculators, you might not get the same thing. See what happens.
The one on the left negative, the one on the right positive.
Well, let's see what happens. Type it in and tell me if you get the same or different. You got the same, right?
Yeah, I got the same.
Okay, now watch this. Change this number to a, Rylan,
Positive.
it is positive.
Negative.
No, let's change it to a 4. Now you tell me if you get the same or your different answer.
Why do we need to change to 4?
Just do it and see what you get. Right.
I get negative 81.
What?
Negative 81.
I get negative.
On both of them?
Hold on.
This one gives you negative 81,
Why?
and this one gives you.
Positive.
Yeah.
So parentheses do make a difference occasionally. He's kind of already told us what the rule is. I'm just going to tell you, when you have negatives and you have parentheses, do not assume that you know what the answer is, right? You got to take into account the fact that you have parentheses. So for the next part, we're just simply going to talk about what are the rules by doing this by hand. Because you got to know what happens when you do it by hand. All right. So the first one, by the way, this is box 4. Box 4. Right. So GEMDAS tells us to do what? Hey, seriously, I don't have time to make the speech again. Pay attention. You weren't. Okay. GEMDAS says to do for what first?
Parentheses grouping.
Parentheses grouping. Do we have any parentheses here?
No.
Okay, what does it say do next?
Equation.
Exponents. Do we have any exponents?
Yes.
So the question is the base 3 or is the base negative 3? And here comes your first, why is math so hard? The base is not negative 3. The base is 3. If it was parentheses negative 3, then the base is negative 3 with parentheses. But when there's a minus sign in front, this is 2 separate operations. This is subtraction and exponents. So we will do exponents before we do subtraction. Over here, because this 3 applies to the whole base right here, now the base is negative 3, or parentheses negative 3. Now the base is parentheses negative 3. But over here, the base isn't negative 3, it's just 3. It's just 3. 3 to the third power is 27. So this is subtract, let me catch up here, 27. This is why your calculator said this one is negative. Okay? Over here, well, this is right parentheses negative 3 3 times. Okay?
So if it's an odd exponent, it's always.
If you have parentheses and you have an exponent, and what's inside the parentheses is negative, then you simply say if it's odd or even. If it's odd, the answer will always be
Negative.
and if it's even, the answer will always be. Now let's make sure we got this right. So we're talking about 3 different scenarios here. This is all got to be in box 4. The first one is you got a negative in front of a number that's raised to a power. What does it say? Always negative. Hey, calculator people, change that to a 4 and tell me what was the answer again?
Negative.
It was negative. Doesn't matter whether it was 3 or whether it was even or odd, its answer is always negative. This is the hardest one to remember. If it's a negative and there's a power, the answer is always negative. Be careful what I said there. I said negative and a power, the answer is always negative. But if there's parentheses involved, you can get a positive or a negative depending upon the power. It is. If the power is odd, the answer is negative. If the power is even, the answer is positive. Now tell me why. Why is this one even? I'm sorry, why is this one positive and this one is negative? Why? She's almost on it. She says because we have an even amount of numbers. What does that mean?
That every number.
What's a negative times this 2? What's a negative times a negative? So when they pair up with each other, that would be even. A negative times a negative is a positive. A negative times a negative is a positive. You're just multiplying with positives. Over here, what's a negative times a negative? What's a negative times a negative? And then you got that one negative left over. That's what makes the answer negative. That's why an odd exponent with parentheses gives you a negative answer. And that's why an even power with parentheses gives you a positive answer. This causes lots of problems. Lots of problems. It seems like an easy thing. Kids mess this up all the time. You don't mess it up when you got a calculator, you're punching buttons. But when you're asked to do this by hand, this is when you make a mistake. This box 4 is really important. You're going to get it wrong if you don't understand this box. Yes? If it doesn't have parentheses and you're dealing with a negative 3, the answer, or 4 or 5 or whatever, the answer is always negative. Doesn't matter. It's always negative. But as soon as we put parentheses, then you're right. We can get a positive answer or negative depending upon whether it's an odd or even power. Who's lost on that basic concept? Okay, what's an odd? How do you define an odd number? Okay. Cool? All right. So here we go. I'm not asking for the answer. I'm asking whether the answer is positive or negative. Positive or negative. There's no parentheses. There's a negative out front to a power. Always negative. Okay. Positive or negative. We got parentheses with a negative and an odd. The answer is always negative. All right. You got the idea. All right. Now, of course, you'd have to do that math. 2 to the 3rd power is 8, so we get negative 8.
36. I mean,
10 to the 3rd power is 10 times 10 times 10. That's 1,000, so negative 1,000. And 6 to the 2nd power is 36, so 36. Okay? Questions? That's Fox 5, by the way. Yeah.
Why are we not doing negative on the first one? Why are we not doing negative?
Because this one reads subtract 2 to the 3rd power. This one reads take negative 10. That's why it's in parentheses. And multiply by itself 3 times. Negative times a negative is a positive. You got that one negative left over. That's what makes it negative. On this one, we got an even number of negatives. A negative times a negative is a positive. Yeah.
So for the very bottom one, did you get 36? You did all 3 sixes?
There's not 3 6s there. There's only 2 6s. There's only 2 6s. 2 negative 6s, to be precise. Okay? All right. Now we'll do a switch. Get it? All right. Hey, now they're going to give you a problem that's in expanded form. They're going to ask you to write it in.
Standard form.
No, simplified would be the same.
Potential.
They're going to ask you to write it in exponential form.
As it's right there. Right there.
Oh, duh. Okay.
Good job, Landon.
All right. That's how I know you're paying attention. So here's how it goes. Everybody paying attention? Look at the board. We gave the definition of exponents as a way of showing repeated multiplication. What is being repeatedly multiplied here? How many 4s are here?
5.
So this can be written as
4 to the 5.
the base is what's being repeatedly multiplied. The power is how many times is that thing? Hey, here's a pre-algebra problem. Not very challenging. We'll show you an algebra 1 here in a second. All right. Hey, what's being repeatedly multiplied?
-5.
Wrong. Parentheses -5. So what's it in exponential form?
It's
Parentheses -5 to the 3rd power. Or cubed. Okay. Got it? We're still in pre-algebra work. Hey, what's being multiplied here?
Parentheses 13.
How many of them?
3.
So parentheses 13 to the 3rd power. Cubed. Yes? Kristen? Prince? So there's an argument to be made of would it change the answer because it's positive, and you are correct. This would be the same answer as just plain old 13 to the 3rd power. Okay? All right. Quickly, what's the answer here? Parentheses -2 to the 4th power. Okay? Parentheses -5 or cubed. Okay? 6 to the 1, 2, 3, 4, 5, 6. Okay, 6 to the 6th power. Okay. Which is a large number. All right. All right. So that was pre-algebra. Now comes algebra 1. Okay. And you're like, well, that's pretty easy. All right. Oh, wait a minute. What's going on here?
-2 times a to the 3rd power.
What did you eat for breakfast?
I don't know.
Can you eat that every day?
Yeah.
Okay. So Tristan is stealing my thunder here, but he already said, well, 2 is not, or -2 is not being repeatedly multiplied, but a is. So if it was just a, that'd be a to the 3rd power, a cubed. Just tack the -2 on in front, and you're done. All right. We will see this a lot in algebra 1.
Wait, don't you click the
Oh, sorry. I thought I clicked it enough. Who's lost? All right. It gets more complicated when there's more variables running around. Aiden. Okay. Aiden, what's being repeatedly multiplied there? Just A? Now we got A and B. How many A's we got there?
3 and 2 B's.
So what should I write?
A cubed, 2 squared.
Yeah, that.
B squared.
Tell me what to write.
You write A squared times, or no, 3A to the 3rd and B to the 2nd.
Well, you're in algebra 1.
Yeah,
All right.
the exact thing. That is no.
Now she said A cubed B squared. What you tried?
A cubed B squared.
You got the
2
cube.
squared.
Yeah, that was the thing you messed up. All right. Now I'm going to cause you to have problems. All right. So this is not a rule. This is more of a math custom. Clearly, how many x's are here? So that'd be x to the,
3rd power.
how many 2's?
2.
To the,
2nd power.
now this is not a rule, and I will never mark it wrong on a test, but mathematicians say writing 2 squared would take too long. Wouldn't it be easier just to write
2.
4? 2 to the 2nd power is 4. This is not a rule. If it's 2 to the 21st power, look up here, please. If it's 2 to the 21st power, that's a pretty big number. Wouldn't it be easier to write 2 to the 21st power? So we do. But if it's 2 to the 3rd power, mathematicians say it would be easier to write 8. There's no rule here. The basic idea is this. If it's easier to write the number in simplified form, you do. If it's easier to write it in exponential form, you do. There's no cutoff, like anything to the 4th power and higher gets written with an exponent. Anything less gets written in a simplified form. tonight for homework, when you look at these problems, some of them will be like 11 to the second power. Well, write a 121 and be done with it, right? But if it's 11 to the fifth power, don't be multiplying that one out. Just write 11 to the fifth power. Have I confused someone? This to me always caused me problems because I'm like, well, I don't know which one you want me to write. Do you want me to write 2 squared x to the third? Or do you want me to write 4x to the third? Mathematicians would say, I would much rather you write 4x to the third. This is a custom, not a rule. If you write this, you are correct. Don't panic. Okay? But I will say, when you look at all the examples in the back of the book for the odd ones, if it's 2 squared, they write 4. Yes. Either way is fine. But get used to this. This is how we always write it. All right. Box 7. Here we go. I got Algebra 2. Or I have what?
G
R to the second power times G to the third power times 2.
Okay, here comes custom number 2. You ready? Are you listening?
Yeah.
Custom number 2 is we will always write number first, then variables to the highest power to the lowest power.
Would it be wrong if
It would not be wrong to say r squared g to the third times 2, but you're never going to see that in the book. It is custom to write number first, which power would be the highest, which power would be to the highest, g to the third would come next, and then r squared. If the power, you got to be paying attention. I'm making up rules now. I'm literally making up rules, right? If you have a variable, 2 different variables, and they're both to the same power, which one do you write first? Alphabetical order. So here's the I don't know, standard, here's the custom. Number comes first, then variables to the highest power to the lowest power. And when you have things that have the same power, you write them alphabetically. Okay? This is what's called, and they do have a name for it, it's called standard form. All right, second one, that's parentheses, -6 to the second power, x to the second power. Mathematicians wouldn't write this, they would write, what would they write? They would write 36x squared. Some of you need some work there on -6 times -6. Yes?
Can we not use variables like ever?
No, you're in Algebra 1. There will be variables between now and the end of high school. You go to college, they can get worse. They start using Greek letters. All right. We will use a few Greek letters. You already know one. Which Greek letter do you know?
Delta. Omega.
Pi.
Wait, that's wrong.
Right? You've used pi before. That's a Greek variable. It's actually a constant, but you get the idea. All right. Last thing is this. Well, actually, two more things left. Look up here, please. Hey. Talia, I'm questioning whether or not you're paying attention. All right. We got 2 things left, and if there's a mistake to be made, this is where the mistakes generally occur. All right. So you will be presented with an expression that will have almost all the letters of GEMDAS. You're going to have parentheses, you're going to have exponents, you're going to have multiplication, division, you're going to have adding, subtracting. We got them all right here. We got multiplication, we got addition, we got parentheses, we got exponents. So it might help for you to write the word PEMDAS, next to it, and just follow it. G stands for grouping symbol, that means parentheses. What do I do first here? What do I do first? So what do I do first here? So I do 3 plus 2, which is, and here's where everyone will screw this up. You ready? Guess what the answer is not? Guess what it's not? Guess what I see a lot of students do now? No, they do this fine.
What they do is they do 4 times 5 and then
They do 5 times 4 and they write 20.
That's not it. You got 2 exponents.
Hey, what's the next letter? M or E? E stands for exponents. Do you see the 2? Yeah. Is it next to the 4 or is it next to the 5?
I mean,
It's next to the 5. The 4 is not being squared. It's the parentheses 5 that is being squared. Are you paying attention, Julie? This is what I'll see students do. Just like they'll do 5 times 2 is 10. It's not 10, it's 25. Okay?
20.
No. I'll see kids do 5 times 2, and they'll write 10. But instead it's 5 times 5 written twice, 5 times 5. Do not do multiplication until you've done all the exponents. This means 4 times 5 times 5. So I do 5 times 5, which is 25, and I get 100. That's pretty different. 20 squared is 400. You will get the wrong answer. You will get the wrong answer. Please don't make this mistake. The second mistake is this. Please stop. Second mistake is some kids they just look at it, they're thinking 5 times 2. It's 5 written 2 times. Okay? Do you understand the mistake you could make here, everyone? All right, do not make that mistake. All right, once again, they're going to give you a problem. You're just going to toss it. Hey, up here, please. Okay. What do we do first? What do we do first? What are we going to do first in this problem? 4 times 2 is, okay, hey, is the negative inside or outside?
Outside.
When it's outside, the answer is always negative. Is the negative inside the parentheses or outside?
Outside.
By box 4, we said whenever the negative is outside, the answer is always negative. Hey, what's 8 squared? Oh, boy. Come on. Remember back in 3rd grade, 8 times 8. 64. So the answer isn't 64, it's actually subtract 64, negative 64. See what I mean? When the negative is on the outside of the parentheses, the answer is always negative. I don't mean the final answer. In this case, it is. 49 minus 64. Now we're back to chapter 2 stuff. Clearly, there's more negatives than positives. We subtract the 2. We get negative 15. Boom. Who's lost?
I'm lost.
All right. Quickly, let's do these together, and we'll get to the last thing, and then we're done. All right, we're doing this together. Box 8.
4.
We do the parentheses first. 6 minus 2 is?
4.
Okay. 4 to the second power is? 16. It's not 4 times 2. It's 4 times 4. 4 written twice. 9 plus 16 is? 25. Chris, when I said we're going to do this, you're grabbing your pencil, you're doing this. Why are we adding 9? Because it says 9 plus. Okay. All right, second one is the most complicated one that we'll do today. Here we go. Hey, is this 3 applied to the parentheses negative 3, or does it apply to the 4? Parentheses negative 3. Hey, I got a negative on the inside, and I got an odd power. Answer's positive or negative?
Negative 27.
Negative. So negative 27. But I got 2 powers. So I got to do this one as well, too. 5 to the second power is?
25.
If you're going to make a mistake, it's because you don't write everything out. You try to do too many steps in your head. Hey, what do we do first? Add or multiply? 2 quarters is? Well, I don't know if you can do 4 27s in your head. Okay, and a positive times a negative is a negative, so we get negative 108. Who's lost? Now we simply need to do this, obviously different signs, so we subtract. 108 minus 50 is 58. More is negatives and positives, so negative 58. We okay?
Yes.
Of everything that we did, this is where we get problems. There's just a lot of math going on here. Be careful. All right, last thing is this. It's the same thing that we just did, except they give you variables, and they tell you what values to plug in, and your life will be horrible because there will always be a bunch of negatives running around. They never make it nice and make the numbers positive. All right, listen carefully. This is new. This is called evaluating. When you evaluate, you must replace the variable with parentheses. I'm going to say this again. When you plug the numbers in, you must replace all the letters with parentheses. You will get this wrong if you don't have parentheses. And I'll show you why. Okay, read this from left to right. What does it say? Negative 2x. Oh, I see an x, but it says x is. So I replace x with parentheses, negative 2 to the third power. Plus 4 times parentheses.
3.
You see what I did? Notice where this power is. Is it on the inside or the outside of the parentheses? The power will go on the outside of the parentheses. Are you listening?
Yeah.
It makes a difference whether it's on the inside or the outside. It makes a big difference. It goes on the outside of the parentheses. The parentheses is what replaces the x and the y. Okay, so why did I need to put parentheses? If I didn't have parentheses, it would say negative 2 minus 2. Literally. If I didn't have parentheses, what would it say? It'd say 43 instead of 4 times 3. You must use parentheses. You will get it wrong without parentheses. Okay, what do we do first on this one? Exponents, odd or even. So is the answer going to be positive or negative? So we get negative 8 times negative 2. Okay, see what I did? One step at a time. What's a negative times a negative? So what do we get here? And 4 times 3 is 12. Therefore, the answer is, okay. Where will you make your mistakes? One, you'll forget my saying here that you got to put parentheses. You will literally write 43, and you'll be happy with it. Like, oh, it must be 43. When you replace all letters, you replace just the letter with parentheses. You stick on the inside of the parentheses whatever it tells you. Yeah, most of the time they're going to make them negative. They do that just sort of, I don't know, cause you problems. If it's positive, you probably aren't going to have a mistake, but when they're negative, you make a mistake. Let's do 2 and call it a day. All right, here we go. Box 9. Box 9. All right, let's read it from left to right. We got negative 4, and then we come to parentheses. And we're going to plug in 3. Make it to the second power on the outside, plus parentheses 3 to the third power. Okay? We have to do exponents first. Hey, check it out. It's positive on the inside. The answer is going to be positive. 3 to the second power is 9. 3 to the third power is. Am I going too fast? Or are we okay?
We're good.
Negative times positive.
Negative.
So we get
36.
different signs. That means we must subtract 36 minus 27 is what? 9. More negative, so we get negative 9. Last one. Left to right. You can go right to left, but left to right. 2 parentheses. J is negative 3. Close your parentheses to the second power. Plus parentheses 4. We got 2 minutes.
Are we eating in here?
You're eating in here. All right, sit. Let's finish. Sit. Sit. Tristan, class is waiting on you. Sit. Sit. Okay. Hey, negative on the inside. Listen, please.
Guys, listen.
Listen. Negative on the inside. What? Odd or even here? So is the answer positive or negative? It's positive. Negative 3 times negative 3 is 9. Hey, watch me. 9 plus 4 is 13. Times 2 is 26. The answer is 26. Why? You got to do multiplication before addition. 2 times 9 is plus 4.
22.
All right, hey, I'm totally 100% serious. You guys are leaving my room a living nightmare of mess at lunch. Occasionally I'm seeing things being thrown, and I'm absolutely coming back after this period, and there's trash everywhere. Look at the floor right now. Okay, there's a few pieces of paper down there. I can live with what's on the floor. You guys need to stop trashing the room. Hey, no joke. None of you are going home today if I find my room trashed. I will send the tiny 7th graders away and you will clean my classroom. Do not trash my room again. All right, go to lunch.
What about the cone of ice?
Yes.
What do we do for the cone of ice thing?
For what?
Cone of ice.
What do we do one more time?
No, the cone
Oh,
of
Kona
ice.
ice. I'm like, what is she saying? I don't know. Miss Boyd knows that stuff. All right, e-learners, do you have any questions? If not, and if you do have a question, send me an email. If not, I'll see you guys tomorrow.